my screen. Okay. So you able to see my screen, which I've shared?
No.
No. Okay. Okay. Sorry. How about now?
Yes, I can see your screen
Okay.
now.
Okay. So I'm going to start now. Yes. So today we are going to, uh, discuss about two things. One is CloudWatch, and other one is storage options. So let's get started with CloudWatch. So CloudWatch is a monitoring service basically offered by AWS. So they give visibility about the instances and other resources. So what this really mean is if we want to track any resource utilization or anomalies which are around, so we could use this monitoring service to track any changes before it really happens. So this would help us troubleshoot in real time, and also this would actually help in improving the customer's experience, and this would actually give value to the business because we are handling the you know um, uh, errors, or we are handling certain utilization problems, or uh, uh, the overheads. So let's see how this what are the offerings provided by AWS on the monitoring service. So there are mainly four services that are provided by CloudWatch. So one is metrics, CloudWatch metrics. So basically these are the data points provided by mainly instances or applications which gives you the variable or the value of the utilization, or uh, disk IOPS and things like that. So alarms are basically if there is any any variation in the metrics, or if you want to track our metrics and it has to be notified, then we could use alarm. And events are something which is system driven. So if there is a change of state in the system, we could use CloudWatch events. And logs are basically to log the system events or application events. And also you can log custom events as well. So let's understand how how CloudWatch works basically. So basically CloudWatch is metric repository, as I told. So these data points are captured from either EC2 instances, or it can be a custom application data points. So they are pushed into a CloudWatch uh, metrics, and these metrics can be used to get the statistics out of that, and these statistics are used to present as a graphical representation in the console, or any statistic, a third party statistics consumer, which can be these statistics can be accessed through APIs. So we also have alarms, which keeps monitoring the metrics, and based on the metric data point and alarm configuration, we can do certain set of actions. So those actions can be or like SNS email notification, or SMS notification, or you can also based on the metric, if it is, for example, if it's a CPU utilization, you can um, use auto scaling group to either scale in or scale out based on the need. So what we have here is, under the CloudWatch we have CloudWatch metrics, alarms, and um statistics to use these metrics and perform certain set of actions. So CloudWatch does not aggregate data across regions. So something which we need to keep in mind all the time. So we can't aggregate data across regions, but we could have a single dashboard, and we could aggregate the information in one dashboard. But the aggregation is again the region level aggregation. So the cross region visibility to your dashboard is available. So the retention period for the CloudWatch is, for 1 minute data point, you get 15 days, 2 weeks of data, and for 5 minutes data point, you get 63 up to 63 days, and for 1 hour data points, you get up to nearly 15 months of data. So after 15 days, you could only have 5 minutes of data points that are available in CloudWatch metrics. So after 9 weeks, you get 1 hour of data point till 15 months. So let's understand what is CloudWatch events. So events, AWS resource can generate events when the state changes. So this can be a real-time stream of system events. For example, an EC2 instance is stopped or terminated. um, we can create an event and have write a certain set of rules for that incoming event, and you can target a particular action for it. Either it can be EC2 instances, it can be Lambda functions, it can be many things. So basically there are, in the concept, if you think ECE events, there are three main concepts. One is event, which is basically change in state of the resource, and a rule that you put in to capture that event and direct that particular set of event to a target to consume it. So also there is a scheduled event, schedule based event, sorry, time based event. So you can create this event to do periodic actions, or if you want to trigger a target based on time, then you could use time based event or schedule events. So target receives events in JSON format, and it has to be processed by the target. So a rules target must be in the same region as the rule. Okay, so let's say if EC2 instance and the rule which you have written should be in the same region. So most of the CloudWatch activities happen within the region. So whether it's an event or alarm, logs, the everything is a region specific. So CloudWatch logs enables to centralize all the logs from different source. So they can be from systems, they can be from custom application, and these CloudWatch logs are highly scalable. Now, basically, these CloudWatch logs can be used to monitor the logs. They are stored and accessed to a log file data. So these are having different patterns in the logs. So you can actually look for the phrases or patterns and create a dashboard or alarm for the patterns. I'll also show how we can create a custom metric for the logs. So basically the typical use case is we usually watch the application logs or system logs. We can even watch the CloudTrail logs. We'll see what CloudTrail is in a minute. So if you want to basically want to know like who has accessed a particular KMS key, you can check the CloudWatch trail, or you can put a monitor to the CloudTrail to publish the logs. So basically the main features of CloudWatch logs are like they monitor logs for EC2 instances, or it can be Lambda as well, or any custom application logs. So we it also monitors CloudTrail log events which is happening. So this is also a typical use case. So there is also, you can set a log retention period for a different time frame. So default would be never expire, and we can archive the logs in S3. And the most importantly, we can capture the Route 53 DNS queries into the logs, so we can watch what were the requests coming into the application. So to understand what CloudTrail is, basically this tracks user activity and detect any unusual APIs or usage patterns that are happening. So you can capture these activities and deliver the events to the console or S3 bucket itself. But you can also push it to CloudWatch logs, which in turn you can create a metrics. You can create a metrics out of those logs and publish to metrics and watch them and create alarms for those metrics and so forth. So you can basically as I said, you can review these events in CloudTrail console, and you can analyze logs as well. If you're pushing it to S3 bucket, you can use Athena to get insights of the logs or data which is captured in S3. So basically this is used for compliance auditing, and if there are any violation in the compliance, so you can have automatic compliance remediation for that as well. So when we say CloudWatch metrics, there are nearly 5 concepts in it, 6 concepts. So alarms are also part of CloudWatch metrics. So you get namespaces. Namespaces are something which actually brings a logical boundary or grouping between the CloudWatch metrics, and metrics is a data point, as you can see. Dimensions gives you again a defined a group of metric data, and statistics is basically with a combination of metrics we can get the statistics out of it. And percentiles are also identified using statistics. So let's understand each one of them. So namespaces, as I told, are basically a logical grouping of metrics. Namespace is a container for metrics. We'll see what a namespace looks like. So basically the namespace can be something like EC2, EBS, a resource name, or a custom app name, and each metric is associated with a namespace. Metric from different namespace are isolated from each other. So um, CPU utilization for EC2 cannot be overlapped with CPU utilization of EBS or disk operations, something like that. But both metrics are isolated from each other. This prevents incorrect aggregation of metrics from different applications. So if you have two different applications running and you have published um, two different custom namespaces, so you could get what are the CPU utilization of EC2 for that particular application that you're using, and you can easily isolate the metrics based on the namespace. So for example, your application is tracking error rate and RDS is tracking database error rate. So these two are two separate things. So they are not mixed together, or they can't be aggregated together into a single statistic. So basic convention is for default metrics, it would be something like AWS slash the service name, AWS slash EC2 name. If you're using an API, you could see this kind of pattern. So if you go to the this is basically a CloudWatch console. You have alarm, you have logs, you have metrics, you have events. There are two more new services which are added. So service lens and settings. Service lens is basically for microservice based monitoring, and settings you get a few tweaks to be done using the settings option. So basically this under metrics you get the namespace. So namespace, as you can see, they are basically isolated based on the services that are available, or AWS services that are available. We will look into more detail on that at a later point of time. So metrics is basically a variable that we are monitoring. Metrics data point represents the value of a variable over a period of time. So CPU is a metric provided by EC2, and time when utilization was observed is recorded with the metric. So there are always metric captured along with the timestamp or time frame, and they are time ordered sets. So with whatever information that you publish into metric in whatever order you publish, but whenever it is retrieved, it is time ordered set. So metrics are retained for 15 months. So whenever over a period of over 9 weeks, you get only 1 hour metrics data point which are aggregated for 1 hour. So metrics are uniquely identified by name. So metric name can be something like CPU utilization, discrete latency, and they are part of namespaces, and also under namespace they'll be part of dimensions. So every metric data points consists of these aspects. They will have a timestamp, they would have a namespace, and a metric name and a metric value, and what dimension they belong to. So dimension can be, as I told, instance ID or volume ID, or it can be many other dimension. So optional unit of measure can be something in terms of seconds and MBs, megabytes, and one more. So let's see what dimension statistics mean. Dimensions provide contextual info of the metric. So basically they are key value pairs. You can assign up to 10 dimension to a metric. So this CloudWatch treats each unique combination of dimension and metric uh, into one unique combination. So a dimension can be, as I told, it can be instance ID, and let's say the metric is CPU utilization. So for the instance ID and the CPU utilization, the combination is treated as one unique combination. So dimension can be used for filtering as well. Whenever either you're using CloudWatch or APIs, console or API, you could use dimension as a filtering option. So for certain service like EC2, CloudWatch can aggregate data across dimensions. So you get this not for all, but for certain services. And for example, if you want CPU utilization across all instances that you have, you could do so using dimensions. To retrieve statistics, you have to provide dimension combination that you have used to publish it. So in this case, if you are taking a CPU utilization and instance ID, you need to use these two combination to get the statistics out of it. And statistics are basically metric data aggregation over a specific period of time. So there are only few statistics available. So these are finite list of statistics. You can get minimum or maximum and some, average, sample count, and percentile. So percentiles are available only if you enable detailed monitoring. We'll talk about detailed monitoring as well. So basically these are default statistics that are available. So you get 5 default statistics. So let's understand what percentile means. um, so median or 50th percentile value basically indicates a value that is greater than 50% of the value, and 95th percentile means 95% of the data is below below that range, and 5% is above this value. So let's say there's a CPU utilization, and the CPU utilization is always below 95%, then that is in an okay state. So if there is data, 5% of data which is above 95% of CPU utilization, then this would create an alarm to be triggered. So this is captured through percentile metrics. So this actually helps. For example, if we take CPU utilization, the average basically may hide anomalies, right? So the maximum of if you take maximum as a statistic option, then a single value can screw the result, right? So if there is just one spike for a second, then it might skew the results, and you don't need uh, alarm to be triggered just for one you know one spike. So but if you want to capture or if you want an alarm to be triggered for let's say for this in this example, for utilization which is always 95 percentage of CPU utilization for a certain period of time that we specify, then we could use it to create an alarm, and this alarm can take necessary actions either to add an EC2 instance, to distribute the workload among them, and bring back the CPU utilization to less than 95% from alarm state to the OK state. So percentile is a very a powerful metric that is used, and this is used quite often when you are when you are targeting some auto scaling groups or some alarms which will actually help you in monitoring the CPU utilization, or it can be memory utilization as well. But percentile statistics is really helpful in many ways. So let's understand alarms and its different states. So basically alarm, what it does is it takes automated action. It can notify through SMS, or it can take automated action as well. And basically these actions are due to the change in infrastructure, and the application for example, some of the examples that are stated here are like application error rate, high CPU utilization, which I mentioned earlier. So if you have queuing service like SQS, and you have a request length getting increased beyond a certain point, you could use an alarm. And there are different states in these alarms. So OK state is when it is below the threshold. So alarm is when it is outside the defined threshold that we have, and insufficient data is when we don't have enough data available for it. I'll give an example for all of these. So let's say we have an EC2 instance, and we have not enabled detailed metrics, detailed monitoring. When we have not enabled detailed monitoring, we cannot get data for every single minute. But let's say we create an alarm for 1 minute data capture. What happens at that point of time is we would not have sufficient data for a period of 4 minutes, or between that 5 minutes. So your alarm would go to insufficient data state whenever between each 5 minute, right? So whenever you get a data point, it would move to either OK or alarm state based on the data points or metrics value. So let's see that in a demo as well. So basically behavior depends on the alarm. So the action, how the action has to be taken place depends on what kind of target that we have assigned to it. So if it is an SNS, the notification can go only once. If we are if the target is auto scaling group, what happens is the alarm can continue to invoke the action we would have set for a specific period of time, and that alarm will remain activated for that specific period. So alarms behavior can change, or the behavior is different for different kind of target service. So be, before we get into EC2 monitoring, I think we'll go and see how, we'll see a demo of CloudWatch. So this is basically a dashboard, and we can have we can set different alarms to it. So this shows different services that are accessing the alarms. So I have created two alarms for my billing service, which we created at our first session, and EC2, I have created another alarm for EC2 service, and you can enable a cross service dashboard if it's required. Since I'm only using North Virginia, there won't be any data there. So there is alarm service. We can go and create an alarm here. Let's go. So I've already created an alarm for called test alarm. This basically is capturing the data points, CPU utilization data points. But let's go and create a new alarm. So once you go to alarm creation, you need to select what kind of metric that you're trying to capture. So let's go to EC2, and I have already enabled detailed monitoring for my EC2 instances. So you get these three metrics available as well. Otherwise you would get only per instance metrics if you have not enabled detailed monitoring for EC2 instances. So let's go to a per instance metric. So there is CPU utilization. There are many metrics available here. You can select whatever metrics you want to choose from. So if you want to choose a particular metric, you need to check the instance ID. So please select which is which you are trying to monitor for a specific instance. If you scroll down, there are many other instances as well. So don't get so if you see this metric balance, if you sort by metric balance, there are a lot of metric balance available for different instances. So before you start any create any alarms, try to get the instance ID, sort it based on instance ID. So you get credit balance, get different data. So you're getting you can see the metrics here, right? So the does not mention anything, is it? Yeah. So you can see the credit balance of this. So there are 32 is being is available. So it is, if you see this if you see this graph, every minute or so it is capturing the CPU credit balance is getting accumulated, right? So here it was already till 30, but uh, basically when you start the application, the EC2 instance, which is in which is a basically a burstable instance, you get an initial credit of 30. So you would have got that. Since I've used application for a certain amount of time, it got reduced to 28. Then again it started accumulating the credit balance. This is this instance is basically a T2 micro instance. It's a burstable instance. So if in our previous EC2 session, we understood that how the credits are accumulated over a period of time, and how it has to be how it is used as and when the CPU or as and when the application is used. So let's go and create a CPU utilization checkpoint. I've selected a metric here. So you have to select the correct instance ID. You can select different statistics here. It can be average, sum, maximum, minimum, and sample count. And you can also select different percentile values, whichever is required, suits your need. So let me for now let me select maximum. I would set 1 minute period. So if you go 30 seconds, you don't have an option. It says that you can't go less than less than 60 seconds. It has to be a minute.
So why there is no option for 30 seconds?
So the data points which are provided by detailed monitoring for CPU utilization metric is at the rate of 1 minute.
But why they are showing no option in the drop down for 30 minutes? Okay.
So here,
Hmm.
right? So there are different metrics options available for
Okay, okay.
based on different metrics you get a period. So ideally they shouldn't show this based on the metric, but they are showing it. So for a different metric you would get this 10 seconds and 30 seconds enabled.
Okay.
Okay, or let's say you have a custom application which is giving you a custom metric, let's say memory utilization, and it is publishing for every 10 seconds, let's say that. So at that point of time you could use this 10 seconds or 30 seconds period.
Okay, got it.
Okay. So it can be, you can select a particular condition. It can be anomaly detection or a static value for a threshold. So basically this is as a band, or static is just a particular value. So I would say greater than just 1% for now, because it's very difficult to load the instance. So let's say 2%. So we can create alarms for different state, when it's in OK state, when it's in insufficient data state, or in actual alarm state. So whenever there is an deviation from the required value, then you would use and in alarm state. So whenever everything is working fine, you just need, let's say, your EC2 instance is down, and you would require certain time for it to be recovered. So you would use this OK state at that period of time. Or you could have a different set of alarms for in alarm state and OK state, and find out when it went down and when it came up. And you can do a lot of different combinations and configure this. Let's say we have an SNS topic. I would say if EC2 instance is terminated, or I have created a SNS notification called EC2 termination. Let's use that. Don't worry about the name. It's just a SNS topic which is configured to an email. Whenever this particular configuration or the previous configuration that we have done, uh, that alarm is triggered or directed to this SNS name topic, right? So you can also create actions based on these alarm. Let's say we want to add another we need to call another auto scaling group or EC2 service, ECS service. uh, then we could use auto scaling action. Or if you want to manually just terminate the instance or stop this instance based on certain usage pattern. Let's say there are 5 instances that you have created manually without any auto scaling group, and you see this instances not being utilized, or the CPU utilization is less than 5%. You could actually stop that instance. You could create an alarm to stop that particular instance. So for now we have created a CPU utilization. You could add a name for it. So let's say CPU till that's fine. Sorry, it's more than 2%. So you could see the actual patterns which is happening right now. So till now the CPU utilization is somewhere less than 1%. Let's go ahead and create an alarm. So if you see this, it is still in insufficient data state, because we don't have any data available for this yet. So after 1 minute you would get a particular data for it. So there are 3 alarms which are in OK state. So maybe after a minute you would see a different pattern in this. We'll come back and see that. Let's meanwhile let's go through what metrics is. So basically, as I told earlier, these are namespaces. Let's say EC2, and let's say these are dimensions. So the previous, these are the dimensions available. Let's say I'm selecting per instance metric, and these are the metrics which are available out there. So these are the different metrics which are available. So you can change a different a graph if you need. So Just this is just a visualization. So basically you can add this to your dashboard if you require, and you can set the refresh interval for 1 minute or 10 seconds. Let's put it to 10 seconds for now. So you can see the alarm has everything is in okay state for now. So earlier it was, since when it started it was in insufficient state because there was no insufficient data. There was insufficient data, there was not sufficient data there. So this is the application that is running. So let's use this application for a while. So probably uh, so this is a ghost application that we launched last time. You can you can create different themes for in it, and let's activate few themes. So some of them are premium themes. If you want, you can buy them, or let's activate a different theme here. So I've activated default Casper theme here, and let's activate a medium like theme. You could actually use this AMI and um, build your own blog post, right? So this is really very similar to medium kind of blog post theme. So let's upload theme, maybe that might help us in. So I'll upload massively. Let's activate. Let's see how. So what we are trying to do is we are trying to increase the CPU utilization. So let's go and see here whether let's go and see the metrics here. So there was a mail for me which was sent. If you see this which was triggered, you can see that there was some mails. This is just a sample mail which was triggered, which says my account number and all that. But yeah, so you can see that there was a CPU utilization for a period of 60 seconds has crossed threshold points. You could get a detailed data about it. So if you check this, if you want, you can actually view have a better view of it if you need. So this is this is for 1 hour. So if you see this, there is a huge drop because you're not using it anymore. So it used up to 2.8 or up to almost 3% of utilization, and it came back. So there were 2 alarms which were triggered. So I had created this test alarm. Let me go and delete this alarm. Okay, so let's understand cloud events. So using cloud event, you can you can track any service, any AWS service system change. So you can have actually the event pattern. You can select based on event pattern. Let's say we say EC2. I would say state change. So we can actually select a specific state, whether it is a termination state or running state or stop state. So these are stopping state and pending state are very useful state. These are basically hooks which you can use to do certain set of actions when let's say when a system is in a stopping state. You can actually uh, you know create another EC2 instance to launch before it even gets into stop state, because from running state to stop state, there would be somewhere around 1 or 2 minutes duration difference. So you could use the stopping state to launch the EC2 instance as and when it is moves away from running state. So for now, let me say we'll go to terminated state or any state for now. You can actually select a specific instance, or you can copy the instance ID and paste it over here, and you can add many instances as well. Let's say any instance. So you can also see here, earlier it was in alarm state. It came back to OK state now. So I'm just setting the target here. So what we did was we set the event source, we set the rule for it, and now we are setting the target. So target can be an SNS topic, or it can be many things like EC2 creation from a snapshot, or a spot instance, or it can be any one of these from the option given below. So there's a finite option here. So I'm going to select EC2 and add target. I'm sorry, I'm going to say configure details. I would say again EC2 termination rule or event. So I'm going to create this event now. So there was one more event created earlier. Let me delete this. Okay. So I have created this event, and what it says is whenever there's a change in state, this event is triggered. So let's go and modify the event. So let me put it to a stop state. So it says ephemeral storage data will be lost. That's it. Instance storage, if any attached, would be lost. What did we just do? Did we stop? Okay. Okay. Stopping it again. So since I got an immediate the mail as well, which says it's in stopping state. You can see here. and it's you can see it's very immediate. It's like as in when you stopped it, you got uh, the notification. So now you can see that there is a different state. From stopping state to stop state, you get another notification for it. So it went from running to stopping and stopping to stopped. So you got two mails or two notifications for a different state. So that's how event CloudWatch events work. So let's get back to our presentation. So we understood there were two monitorings. One is basic monitoring and detail monitoring. Basic monitoring is automatically enabled, and we have some 7 pre-selected metrics which are available for uh, every dimension or every namespace. So there are three status which are available. Status check metrics. I'm sorry, there are three status check metrics that are available at 1 minute frequency. So you asked me earlier, why is that we have only 1 minute, and how about 10 seconds and 30 seconds, all that, right? So in one of the custom, if you build a custom metric, you can actually use below this 1 minute frequency as well. So there is no additional charge for it, and there is also a detailed monitoring. Sorry, I couldn't show that detailed monitoring. Let me quickly go back to the instance and show you how to enable that detailed monitoring. So if you go, you just have to select the instance, and you have to enable, you have to go to CloudWatch monitoring and enable or disable this detailed monitoring. You can add alarms to it as well, so you can see the alarm status here. Let me disable this for now, since I don't need the detailed monitoring now. So you can enable again if you want. So you can see the additional, it says additional charges applies. So there is also something called as memory metrics, which is not provided by default. So if you need to monitor the memory, um, you need to run the script on your own and schedule it and capture the metrics. Amazon provides the Perl script to do that. You can set it as inside the log agent, or inside your instance. You have to run that inside the instance, EC2 instance, and get the metric data. So you can publish this metric data at any frequency. You can even send it for each second if you want. So that can be captured in your metric console. So there are three different status checks. One is system status check, instance status check, and there are also custom metrics that you can use to uh, monitor the status checks. I'll quickly show that as well, so that it will be easier for you to understand. So I'll go to all metrics, and I would select I would select a particular instance, and you can see here, so there are three different status check. One is for the system, and one is for the instance, and other one is a general system status check. So that's what we are trying to understand. Yeah, you can see how whether the system has failed or not with this system test check. So let's go back. So let's understand basically what these automated system status check means. So this basically monitors health of underlying system, and basically we can't fix these problems or anything which is happening related to a system, but we can get notified and we could take help of AWS support and get it resolved. Or if say if some instance is having a problem, or a host, physical host itself is having a problem, then we could actually restart the start and stop the uh, instance. When you stop and start the instance, the actual instance is moved away from the physical host. So if there is any problem related to a physical host, that could be mitigated. So if there is any other system problem, you could get notified and you can take AWS support help. So there is also automated instance status check. So basically they monitor the individual instance, and it is monitored every minute. So it requires mostly our involvement. So if even if the system fails, a system status check fails, instance status checks fails as well. And if there is any exhausted memory or corrupted file system, or some startup configuration modification to be done, so we need to handle might need to handle all of that. So basically this just gives us the notification or intimation of any failures in the instance. So custom metrics are basically published using scripts, with the help of scripts. And Amazon has provided Perl scripts, as I mentioned earlier, for a memory or a disk, Linux swap space, or disk space utilization, and all that. So CloudWatch log also monitors the log files, and it can push the metrics data as well. So we can create a custom metric using CloudWatch logs. So CloudWatch log basically can as I said earlier, can capture application logs and system logs, and they can monitor specific based on terms or count of occurrences. And these logs are from EC2 instances, and they are in real time. So there are also cloud log agents which collects the log from hosts, and they can publish to the CloudWatch logs. So you can push the logs to S3, which will be you can set the retention time as well. But if you're not pushing to S3, it would be stored indefinitely as well within CloudWatch logs. So this is just basically an architecture of how CloudWatch log looks like. You have a CloudWatch, within that you have CloudWatch logs, and within CloudWatch log you have something called as log groups, and each log groups consists of streams, and each stream consists of log events. So basically log events are each activity recorded by it can be a custom application or a system. So each log events has timestamp and about information about the event. They are basically individual logical record, and log streams are basically these sequence of events from the same source. So these streams are created as and when there is a different instances of the application or different instances of a particular resource. So they can capture log files on a specific host, and this is just an example. And if there are 10 different hosts and 10 different hosts are publishing these logs, and it would create 10 different log streams for each host. So log groups are basically created to group uh, all the 10 different log streams that we spoke earlier. So they share the same retention period, and it is used to access the streams and logs at one particular place. So fleet of servers generating the same type of logs are part of this log group. So we can create something called as metric filter to publish this metric data from the log group into the CloudWatch metrics. So we can use a certain pattern and push it to the CloudWatch metrics. We can also specify a retention period for this log events which are created. So let's quickly go back and see how it is done. So there is log. There's also something called as log groups. There are a lot of log groups here. I'll take an example of a log group called SLS EMP. So this is a log stream, and this log is created from AWS Lambda. So AWS Lambda is the namespace which is used, and if you see, there are logs and there are a lot of errors here. So if you want to create a metric out of this, you have to go to log groups, and let's create a metric filter. For this we can say error. Here we can test pattern for this error. It says there are no errors in this. So there are 9 matches found. This is just a test pattern for this filter. You can assign a metric. You can create a metric name. Let's say lambda error. Create filter for this, and you could could create an alarm if you need, and the action alarm action is as how we created earlier. So let's see what log insights are. Log insights are very helpful when we are trying to understand the log data. So let's take an example of the most expensive request. So before doing that, let's select a log stream. So sorry, this is a log group. I have selected a log group, and I've selected the most expensive log, and I'm running the query. Okay, so there is no data available here. The reason might be this. So I have selected 1 hour. So let's go and select for some period and run the query again. So as you can see here, there is a build duration of 700 milliseconds, which is the most expensive request that we can find. So this insight is really helpful in identifying the most expensive, or it can be any, you can write your own sample queries and find out the respective data that you are looking for. You can just type error messages, or I'll just type error here. No, I'm sorry. So in this case, it just checked for the name error, and it found all the matched logs here. So this is a very powerful tool if you want to find based on a single word, or based on a particular pattern. So that was all about CloudWatch, and we understood how CloudWatch metrics, CloudWatch alarm, CloudWatch log, and CloudWatch event are used, and they are a powerful monitoring tools. So please go ahead and explore more about CloudWatch metrics, because they are uh, one of the important services provided by AWS in handling the errors before it happens, or handling a certain mitigating certain problems before it happens. Let's move on to storage options offered by AWS. So there are three different kinds of storage options that are provided by AWS. One is file storage, another one is block and object storage. File storage are basically organized and represented data in a hierarchical order of files and folders, how we have in our systems. So data are stored in a single piece of information inside a folder. Block storage are very different from the file storage. So they what they have is the data is chopped into chunks or blocks and stored in separate pieces, and these are placed in such a way that it is the system which is running the block storage will identify a most convenient place for the size, depending on the size of the block, and it would be placed and retrieved in a in a different pattern, which will give you the whole complete block when you, as and when you request. So there would be some a pattern where blocks are stored based on the availability of the blocks. So object storage basically manages data, and it links based on the metadata, associated metadata. The data is broken into discrete units called objects and is kept in a single repository. So we will find out what are the different offerings provided by AWS for these storage options. Before we move on, we need to understand a storage unit used by AWS. So storage unit used by AWS is basically called KIB, MIB, and GIB. So they go in the pattern of 1024 bytes. Since there are different storage units used, when it comes to computer memory, we use 1024 bytes, or it will be 1024, and when it goes to SSD and hard disks, it goes like 1000 bytes. So there are some differences in that. So there is also something called as KIB, MIB, and GIB. Uh, KB byte, MB byte, and gigabyte. So Amazon uses those standard. So let's understand some of the storage options available or provided by AWS. So there are 4 storage options provided by AWS. One is uh, Elastic Block Store, and there are Instant Store which are available. So there is also something called as Elastic File System, which is a file storage, and there is S3, which is object store. So as EBS name itself specifies, it's a block storage. And there is also something called as this instant store, which is part of the host system itself. Let's understand each one of them, how and what their functionalities are. So instant stores are basically part of the host system itself. They are carved out of host systems disk subsystem, which means that a virtual storage is provided within the host computer itself. So as and when this feature would have both advantage and disadvantage. So basically the advantage is it is fast, and it is mainly used for buffer or cache data. And the disadvantage, if you want to talk about disadvantages, uh, if you stop and start the instance, as we discussed earlier, the instance will be moved to a different host. There is a good chance that instance is moved to a different host. Hence the storage which is occupied in this host would be lost, would be made free. Hence if you relaunch the instance, or if you stop and start the instance, the data is lost. But if you are rebooting an instance, the data persists within the host. So be aware of it. In system architect associate exam, this is one of the questions that might be coming in, like what happens to the storage when the system is rebooted, or the instance is rebooted, not the system. Let me correct it. Okay. So there are specific instance types supported for this. So not all provides instant store. So you have to, whenever you're choosing an instance, you have to check based on the instance type whether it provides instant store or not. So instance store are not separately charged. It is part of the instance pricing. So whenever you're selecting the instance, the cost of the instance store is also part of the cost. Okay. So let's understand what Elastic File System is. Elastic File System is a scalable file storage for EC2. So what it means is, whatever the load is, the scalability is fully managed by AWS. You can actually mount this Elastic File System to many instances, right? So that is not the case with Instant Store. So with one file storage system, you can mount it to thousands of instances, and you would get the most advantage part of it is you can have a concurrent access from different instances. So this file storage can grow and shrink automatically. You can have automatic replication across multiple availability zones in a region. which is not available in any of the other storage options, that is Instant Store and Elastic Block Store. So this also provides you a low latency access, and this is not supported on Windows for now. So we have something called as Amazon FSx for Windows file server, that is very similar to this option. So quickly let's go through what S3 means. So how it helps EBS, that is block storage. So basically S3 is object storage service, and it is accessed mainly through internet. We can also connect it through as we discussed earlier, we can also connect it through virtual endpoint. So these are reliable and it's inexpensive compared to other options which are available, but they have got their own limitations. And so these are again, this provides you the automatic replication across multiple availability zones like AFS, but in Instant Store and Amazon EBS doesn't provide that. So S3 has lifecycle policies which you can use to manage um, um, certain set of actions after a certain period of time. Let's say you have created an object and you want to move it to a different class. um, let's say after 30 days you have to move it to a archive location or uh, uh, to an infrequent access class, then you would use lifecycle policies. So EC2 uses S3 to store EBS snapshots and instant store backed AMIs. We'll look at all of this. So Elastic Block Storage is a it's a primary storage used for instances. It's a block level storage volumes. You can either there is the option to encrypt the EBS, and EBS volumes behave uh, raw and they are unformatted. You need to uh, basically format it, but now I think most of the device they're also providing with a formatted option. You can attach to a single instance only. In EFS you can attach it to multiple instances, but not in EBS. You can attach only to one instance, and but instance can be attached to multiple EBS volumes. You can it's decoupled in a nature that you can detach and attach to any number of to another instance at multiple number of times. So this provides automatic replication across only one availability zone. So internally they are replicated within an availability zone only. So they this is a model of pay only for what you use. So you need to allocate a certain amount of storage that you need, and you would be paying for that allocated storage. This constitutes low latency performance, and there is also a mechanism called snapshot, which is basically copies the data available in the EBS into a backup volume. So let's see how it is done in a moment. So snapshot is stored basically in S3 and it will be stored in a region level replication. So you have to go to if you want to replicate snapshot, you have to go to S3 and level and copy the data into a different region and use a snapshot to create the volume again. So basically you can create EBS volume from snapshots and attach it to another instance. So we were talking about encryption option which were available for EBS. So when you launch EBS, you can launch it with encryption volume. But after you launch an instance, you cannot directly just encrypt the volume. So if you want to encrypt the volume again, you might have to create a snapshot, and during the transit you have to encrypt it, and or you can create an unencrypted snapshot, and from the snapshot when you're creating a volume you have to encrypt that. So uh, when the data is at rest, you can't encrypt the EBS volume. So this the reason is very simple. The reason is that the encryption happens at the host and host system that is having an instance. So this encryption cannot be done when the data is at rest. So so there is also something called as KMS. So this is a key management service. Key management service is our encryption solution. So we can use keys provided by KMS and encrypt the data, or we can use our own custom key and encrypt the data as well. So data stored, whenever you encrypt a EBS volume, so data stored at rest is encrypted. So disk IO, whenever the data is in transit, is also encrypted. Snapshot from the encrypted volume is also encrypted. So there is something encryption strategies that you need to understand, and there are few questions which are again asked related to encryption in solution architect exam. So basically KMS is a symmetric encryption algorithm used. So symmetric is basically means there will be one key, and the same key is used to decrypt the data. Asymmetric is basically a public and private key encryption that we saw earlier, which was used to SSH into another system. So that is basically asymmetric encryption. And as I told earlier, you can create your own custom master key in KMS. What it provides is a granular access control. Rotate keys. It can rotate. You can rotate keys periodically. Let's say if you feel the key has been exposed and you want to add or define another key, you can do so. You can also disable the keys, and you can audit the usage of these encryption keys using Cloud Trial, and you can publish those trial logs to CloudWatch log and get some insights out of it. So you can actually find out who has used it, and you can also create alarms, and you can do many things with these data. So there are four kinds of EBS volumes: general purpose volume, provisioned IOPS, and throughput optimized HDD, and cold storage. So there are mainly two use cases here. One is IOPS and throughput. if you are looking for more of IOPS, you could go with SSD based hard disk, and if you are more looking for more of throughput, you could go with HDD hard disk volume types. So what is IOPS and what is throughput? So basically the number of read and write operations are used to find the IO operations per second, mostly used for OLTP transactions, and it's basically if you are deploying a Cassandra database within your EBS volume, then you might have to go with provisioned IOPS SSD or general purpose SSD. But if you are looking for um, more of data transfer, and you could basically use throughput based volumes. So throughput is number of bits transferred per second, or number of data transferred per second. So basically used for data, big data Hadoop or Kafka streaming. So there are, as I said, there are 4 volume types. If you are not sure of what volume to choose, then you could always go with general purpose SSD. So keep in mind that general purpose SSD have certain limitations as well. So the limitations are like it gives you baseline performance of 3 IOPS per GB, but it starts with 100 IOPS. So whether you choose uh, uh, 10 GB or 20 GB up to 33 GB, 33.33 GB, you would get 100 IOPS, and above that you would this IOPS gets incremented uh, per GB basis, and up to 16,000 IOPS and up to 5,000 that is 5.3 TB, you would get different IOPS range. So these are designed for IO intensive workloads. So even these are also used for throughput based workloads. But if you have in any if you're starting with a volume type, start with general purpose volume type. You can always move from one volume type to another volume type as need basis. So uh, if you are very much uh, aware of your use cases, then you can use a specific volume type. So maximum throughput that you could get is 160 MIB, and these are ideal for boot volumes, okay, and small or medium databases. These are ideally used for development and test environments. So if you want to move it to production, probably you could go to provisioned IOPS, but you can always use this general purpose SSD for production as well, but mind the IOPS which is provided by the general purpose SSD. So provisioned IOPS are suitable for high random IO, and it can go up to 20 IOPS, maximum of 20 IOPS, and throughput can go up to 320 megabytes, and you can get maximum of 50 IOPS per GB, wherein general purpose used to provide 3 IOPS per GB. This is ideal for mission critical usage and databases if you're using. So there are hard disk based volume type which I mentioned earlier. So they are uh, low cost magnetic storage. So if you are looking for something huge throughput and to save some cost, then you could always go with uh, these two options. So if you're looking for a high throughput, go with throughput optimized HDD. And if you're looking for a moderate throughput, which is if you need better than a general purpose but a moderate throughput, then you could go with cold HDD. So ideally, the workloads are like big data, map reduce, or data warehousing. You could go with throughput optimized HDD. And for this particularly, like if you are placing a large sequential files, if you have TBs of data, or a zip file which is a TB, or in huge size GBs or TBs, you could use cold HDD, which comes with a low cost and also a moderate throughput. So these can't be used for boot volumes because of its low random IO. So there are certain comparisons which have captured here. Um, please go through this offline. You would get more better idea of uh, differences between the SSD and HDD, and when these has to be chosen over the other, one over the other. So yeah, so there are different options which are available. Most importantly, as I said earlier, you would get in any case maximum of 16 terabyte in any volume option. So this 16 is the maximum volume size. 16 TB is maximum volume size that you could get. So there are something called as EBS optimized instances, and these are basically instance types which are specifically designed to communicate with EBS at by providing high performance. So these are optimized for with a configuration, a particular configuration stack, and these are having a dedicated capacity for EBS input output. Also note that EBS optimized instances, when using EBS optimized instances, if you're using an encryption along with EBS volume, encryption will not be part of the EBS computation. So encryption happens in a different Nitro hardware. So uh, whether you use encryption or not, the performance of the EBS volume is not hindered. So you don't have to mind the encryption whenever because of the performance, because it is handled uh, by a different hardware, and it would hinder your EBS performance. EBS, for general purpose SSD, it is designed to deliver the baseline and burst performance 99% of the time, and same goes with provisioned IOPS and throughput. So I have added a link here. It gives you the maximum performance and the baseline performance. Please go and check that as well. So let's quickly go through the what snapshot is. Snapshot is basically point in time data of the EBS volume. It is stored in S3, and the starting point of an EBS volume can be a snapshot. From a snapshot you could create a volume, and you can also, while creating the volume, you can change the volume size as well. You might have created a snapshot using 10 GB volume, but you could always create a volume out of the snapshot with 20 GB or 100 GB, with your desired instance, with your desired capacity. You can also share the snapshot with the other accounts, um, or even you can make it public such that um, community users can use your volume or use your snapshot to create their volume. So EBS volumes are created in specific availability zones. So um, these snapshots are uh, having a boundary of availability zones and a region as well. So these can be attached to any instance in the same availability zones. You can detach and attach. To use across different availability zone in the same region, the EBS has to, you have to create a snapshot and restore the snapshot to a new volume in the different availability zone. To use across different region, you have to create a snapshot, copy the snapshot in S3. You have to go to S3 and copy this snapshot to a different region, and then using that snapshot from that region, you have to create a new volume. So snapshots are created, snapshot data is created incremental in nature. So let's quickly understand how snapshot is created. Let's say there is a 10 GB data. So as and when you take a snapshot of that, a full 10 GB is captured. Let's say in that 10 GB, 4 GB of data is changed. So what happens next is another snapshot is created with only 4 GB of data, and another 6 GB is reference to the old snapshot which was created earlier. And let's say at later point of time, a 2 GB is added to the same 10 GB volume. What happens to at that point of time is another snapshot is created with 2 GB volume, and the 4 GB data which was changed earlier refers to the old snapshot B, and another 6 GB refers to the snapshot A. So in total you would get, the snapshot storage would be somewhere around 16 GB. That is because snapshot A has 10 GB plus snapshot B has 4 GB and plus the new volume, that is new storage, um that is 2 GB, is all added into 16 GB of storage. So if you have actual volume of 12 GB data, the snapshot would take somewhere around 12 GB, 16 GB of data in your S3. So you need to understand that a snapshot are, whenever you create a volume out of snapshot, they are lazily loaded. And if you are accessing a particular block which is not yet loaded, then EBS handle, even EBS can handle that situation as well. It will go and fetch the particular block which you have requested for, but there might be some latency in it. To minimize the latency, you can force download using certain commands, Linux commands, preferably like FIO and DD. So snapshots are encrypted volumes. Encrypted volumes are automatically encrypted in snapshot, and during copy process you can encrypt the volume from an encrypted unencrypted snapshot. You can also re-encrypt a snapshot with a different encryption key while copying. You have the option to share the snapshot with others. So basically, if it is an unencrypted snapshot, then you can share it with with the other accounts, or it can be public sharing as well. You can have if the snapshot is encrypted, public sharing is not allowed, but private sharing is allowed with the encrypted snapshot. As I mentioned earlier, you can always copy the snapshot to a different region if needed. So you can always increase the EBS volume, but it happens through a certain set of process. So the process would be, you need to stop the instance, take a snapshot of the volume, create a new volume with that snapshot, and you need to change the desired volume and size. Then you can detach your old volume from the instance, attach a new volume to the instance with the same device mapping. So this is the process, these are the steps which are involved to change the EBS volume type, EBS volume. So you cannot, when the data is at rest, you cannot change the same EBS volume by certain by single click. So it requires a life cycle to be followed. So EBS, you can have EBS monitoring. So it can be accessed through CloudWatch. So key metrics are something like throughput, IOPS, the bandwidth that is used, latency, and so forth. So you can also have automated system checks every 5 minutes, when if the device is basically if if it can detect the impairment of the device, or not enough storage. So this is a good use case when your EBS volume is running out of space. You could trigger an alarm, and you could attach a new EC2, you can attach a new EBS volume to your EBS instance with the help of snapshots. So there are certain service limits to it. So AWS sets resource limits on per region basis. So some limits are soft limits, so you can contact AWS and increase those limits. So there is a limit of 20 EC2 instances at max that you can run. Hence, you can have aggregated provisioned IOPS of 40,000. So this 40,000 is spread across this 20 EC2 instances, and the maximum storage is 20 terabyte. And you can have, we already discussed that elastic IP, there can be maximum of 5 elastic IPs which are there, and 5 VPCs per region. So to Just have a quick comparison between storage options. The latency is lowest in is instant store and highest in S3. EBS also provides the lowest uh, latency. When it comes to EFS, it is somewhat higher than EBS. Throughput is high in instant store. So if you are looking for high throughput volumes, you could or a temporary storage, you could go with instant store. But in EBS you could get in single GBs, but in EFS you could get at multiple GBs as well. And this throughput is managed by S3, so you don't get to manage the throughput in S3 option. So there are when it comes to concurrent usage, only one instance can access this instance store, and EBS can be accessed one at a time. But the same EFS volume can be attached to multiple Linux instances. The scope of this instance is instance store is one instance only, so it depends on the host. The scope of the EBS is availability zone, and EFS is the whole VPC itself. It can't go beyond one single VPC. And S3, it is internet based, hence it can be accessed from anywhere. So storage options which are available for instant store are SSD and HDD, and these are EBS. Same goes with EBS, and in EFS and S3 it is managed. And there are certain usage priorities. So if you are using for boot, you got to go with instance or EBS. You can't go with EFS or S3. So let's finally go through the pricing options. The pricing options which are available are like this. So EFS is the most expensive one, and general purpose is in a average price. So provisioned IOPS are uh, priced at 125 12 cents per uh, per month per GB, but they provisioned IOPS are calculated with provisioned IOPS as well. This is GB cost per GB, price per GB, and this is price per provisioned IOPS. So provisioned IOPS costs include both uh, storage cost as well as input output cost. EBS throughput costs around 4 cents, and cold storage is the cheapest among all of this, so it costs around um, 2 cents. And per month per GB, this is all per month per GB. And volume storage snapshot costs around 5 per GB, 5 cents per GB. So let's go through some of the instance. So if you want to go to EBS, if you want to check about EBS volumes, you have to go to EC2 service. Go to EC2 service. Under EC2 service, check the elastic block store, check the volumes. You can create volumes with different volume types. So there are 4 different volumes type. There is also a magnetic standard, but these are mainly used for this is the cheapest one which is available, and not compatible with all the instances. These are meant for legacy instance type. So if you go with general purpose, the standard, let's say 10 GB, and you can see that you could get 100 IOPS. The maximum is 3000 IOPS. Even if you say 30 GB, you still get 100 IOPS. So let's say 10 GB, and you can create across any availability zone. The throughput is fixed based on the IOPS or the GB that you're using. So you cannot change the throughput here. If you go to provisioned IOPS, uh, you can change the IOPS based on whatever IOPS. Even for 10 GB, you can go up to 500 IOPS. So based on, if you go with throughput optimized HDD, you can see the throughput available. You get up to 20 Mbps throughput. So if you go beyond, let's say 1000 GB, you get 40 Mbps throughput. So if you go with cold, you get even lesser throughput. So maximum is 79 Mbps. MIB. You can also create, snap based on the snapshot which are available, and these are community based snapshots which are available. So you could go and if you want Fedora Cloud or certain snapshots which are available for free, you can use and you can create volume out of it. So here is a toggle for encrypting the volume. It's always advised to use the encrypted volume. It's a recommendation from AWS. So let's go and create some a 10 GB volume, and we don't know this snapshot. Just let's create a volume. We created a volume. So volumes are 10 GB volume is available with 100 IOPS as of now, with availability zone of 1B, which is North Virginia. So let's go and create a snapshot. So snapshots are created based on a particular volume or an instance which are available. So we have an instance here, and you could just create a snapshot out of running volume or volume which we just created, right? So let's go and check the volume ID with the one which we just created. Okay, this is the volume which we created. Let's go create a snapshot. Okay, let's select this. So you cannot encrypt this because we didn't encrypt that earlier. So it says the volume is not encrypted. Let's create a snapshot. So now a snapshot is getting created for 10 GB of data. So this 10 GB is basically would be replicated in the S3. So there are different volumes here, and snapshot is created now. So let's create a volume out of these snapshots. Sorry, mistake. Let's go to snapshots which we created. So this is the snapshot that we created, right? So let's go and copy the snapshot ID and go to volumes, and you could create out of the same snapshot, you could create a volume. Now you could encrypt this volume. Earlier with the previous snapshot, the volume was not encrypted. Now you can create a volume with, this is a default master key that is provided by KMS. You could also add a custom CMS in customer managed key in KMS and add a master key here for that. So we are creating this volume in US East 1, or you could also create in a different availability zone if you need. Let's create this volume. Can we create that? Yeah, it's getting created now. So you could see that it is getting created in a different availability zone with, now we created a 100 GB size. So size is somewhere around 100 GB and we are getting 300 IOPS. So earlier we created a snapshot from 10 GB, and now we created a size, a different volume size of 100 GB volume. So we could get somewhere around 300 IOPS. So there is also something called as a lifecycle manager. We could create a snapshot lifecycle policy of let's say we have a different schedule based schedule based snapshots that we want to create, and we could add a, let's say for every 24 hours you want to create the snapshot of your volume. You could use this life cycle policies and create snapshots. So you could also, if you have created a volume, you could also create a AMI out of it. So you could modify the volume, but you could also delete and attach the volume. Let's go and delete the volume for now, which we created. So it goes to deleting state and then a deleted state. From snapshot, let's you can create an image. This basically means you're going to create a Amazon machine image. So it can, let's say, let's call it a demo image. Okay, so you can check for virtualization type, architecture, different architecture that you want to change, and different size in volume. You can attach volume and you can create this. So let's create. So as and when you create a AMI from the snapshot, it would be part of this, and we create, as you can see here, this is created. This Amazon machine image is created. You can launch this your instances using this image. When you say launch, you can select the instance type. So it would certain things would come pre-selected in this. You can still change the pre-selected options you want, but as you can see, it's already 10 GB selected and it is created from the snapshot. I'm not added any tags here, sorry, so this comes with a default security group, and you can review and launch this. So basically, with the help of snapshot, you could create volumes, and also you could create AMIs, so that this becomes like a blueprint for creating your instances. That's all that we had on EBS volumes. So I hope you would go back and check all this, right? So probably I would suggest you to go through the most important aspect of how snapshot works, and also uh, um, this chart. So this would help you in understanding which volume types to choose, uh, or one over the other. So it would take a certain amount of time for you to understand, for everybody to understand. So uh, this you can always go back and refer the um, white papers published by AWS. That would really help you in understanding more in depth of EBS. Yeah, thank you. So I would be publishing the